Hi, I'm here to give a presentation about my robotic career. When I was young, I was so interested in robotics. So, I'm a self-motivated person, so I learn everything on my own. Initially, I was learning about wheeled robotics, but later then I have noted that those wheeled robotics are not adaptable in unconstructed environment. And then in rough terrain, it won't make much impact. So I moved on my thoughts to leg robotics. So at the third year beginning, I done my own project, not my own project, learn something from a book called Pick Robotics. Then I tried to implement myself the Exabot walker. The Exabot walker, we already know that it has 6 legs, and each leg is driven by one servo motor, the DOF of this Exabot walker is per leg it has 1 degree of freedom, so that it can move like zigzag seesaw, zigzag seesaw. So here it's the picture of the Exabot walker which I done, and this black hole, this black color represents that the legs are in step. That means it is in the land. In this white represents that it's in air, not stable. That means what we are in, my leg is in the wall. Okay. Then if robot tends to move, it forms like a triangular-like project. When this left leg tries to move, then it must be in air, so it won't support the robot. So remaining legs, the center leg must be go down, and then right legs must be hold in the stand, so that it forms a triangle. So it must be stable. It's a tripod gate. It's the degree of stability is shows it. So, but this Exabot walker may not be adaptable in a rough terrain, even though it has legs, since it can pull legs like ourselves or like mammals. So it has a serious disadvantage that it can adapt in a rough terrain. So I learned from that basics. I move on to my own project. It's my own project, quadruped walker. It has 4 legs. Each leg contains 2 servo motors. One is high torque and another low torque, because upper leg usually requires high torque to move and also to give power to the lower leg. And lower leg servo motor, here it likes it can get low torque, so that it can move along this lower leg alone. So totally I used 8 servo motor. In that 4 servo motor can hold up to 5 kg torque, and low servo motor can hold up to 1.5 kg torque. This is my overall block diagram. I used Atmega 16 controller, and then I tried to use bug algorithm, but I cannot able to complete my project since I don't have knowledge about the embedded system at that time. I tried to implement and code the software, but I can't able to run since I don't know about the hardware related problems at that time. And then this is my design. Before going to my design, and I have my friend teach me about little knowledge about the physics to know about statics, dynamics. With that knowledge, I design my own leg for the robot. These are the issue I gathered. Here L1, L2 represents I choose the leg, upper leg and lower leg 5 cm. I choose the equal arm like us, and then weight of the motors, and with that calculation I choose the motor M1 torque as 0.3 Nm and M2 as 0.05 Nm. 0.3 Nm approximately equal to 4 or 3.5 kg torque. This is the algorithm, shows the working of our algorithm. Actually this is the source, and this is the target. Actually it has 2 classes of algorithm, class 1 and class 2. Class 1, and when it starts, it completely encounters the object and then it moves to the other object. But in class 2 algorithm, it hits at a point, it finds a way such that it can reach the that main line, so that here so it starts from here and it's at the target. Here this is the main line. When the robot encounters the object, it starts first hit point and then wanders around the object till it finds the main line. When it encounters the main line, and again it starts from into the main line till it finds the other hidden objects. So till that finally when it reaches the target, it stops. When class 1 algorithm, it encounters full object and then moves to the mainline. But the class 2, when I found the mainline, it leaves from the an object. Then when I was doing the Hexabot Worker project, I was not able to code completely. I know the concept, but I am not able to complete the project because at that time I don't know about the programming, the C program, and then embedded and microcontroller side. So it was a huge loss for me. I have spent more than 5 to 6,000, but I can't able to complete my project. So taking the negatives from that, I tried to build my own project, that's Quarter Per Worker. I learned C on my own and some part of controllers. With those ideas, I tried to implement this Quarter Per Worker. But this mechanical part itself takes more than 3 or 4 months to complete. But in parallelly, I was developing my code, but I had only 2 days to only left 2 days to finish this mechanical project and to run this project. But actually for running this, actually at least it takes 1 or month or more. But at that time I not have those time, so I can't able to complete this project. But now I know hardware related issues since I was working in Celsius. It's a R&D department in embedded engineering, embedded related side. So at that time I learned something about hardware related problems when it come to real world than simply working in code. But at that when I was working my project and my final year, I don't know about simulation softwares and so on. But now I have some ideas. So now if I continue my project, I may complete to finish it. And this is my small intro about me. Thank you.